Okay, you guys, this is section 4.4. It is an important section. Everyone seems to remember L'Hopital's rule when they go through Calc 1, and that's one of the things that we study right there. The story is, excuse me, taking limits, and I think I hinted at in either a lecture or one of these recordings that when we get to graphing and we have a curve doing something, it'd be nice to know very quickly what kind of horizontal asymptote it might have. And so that's the main purpose of studying this. And so what we'll do is we'll go through limit taking again, basically going back to what we know about how to find limits. Then we're going to have to deal with indeterminate forms, and for those, we need L'Hopital's rule. So first, what I was doing when I wrote this thing up is I was saying, well, what limits do these guys know? We know a lot of different limits, and these are what I would think of as the so-called determinate kind. I mean, you can look at it. So if like a limit ends up being, for example, oh, I plug in the number and I get 0 times some other number, what happens there? Well, what happens there is if you take this limit, remember, when you take limits, oftentimes what you do is you just plug in this thing. We're looking at limit as x goes to 0 of this expression right here. So we plug in 0 for x times cosine of 0. We end up with 0. Cosine of 0 is 1. Well, answer 0. So we know that kind of problem. We know this kind of problem if I get 0 over m. Okay, so once again, we're approaching 0, this time from the plus side. And all I'm going to do is plug in the number. I'm going to go sine 0 over 0 minus 3 is sine of 0 is 0 over negative 3. And guess what? Answer 0 in this case. So if 0 times a number, 0 divided by a number, you get 0. Sometimes we get infinity times a number. And we should, so I'm going to box these in and say, whenever we run into something like that, infinity times a number, we can make our answer. So in this case, what we're getting is the limit as x approaches infinity, e to the x times x over x plus 1. I'm going to plug in. I know I cannot plug in infinity, but I'm going to look at it anyway that way. I'm going to go infinity over infinity. Okay, so this actually, I accidentally put that one in there. This is a so-called indeterminate form, but I was kind of thinking maybe you know how to do this guy as x goes to infinity. Let's work on that one. So yeah, I've got the lim as x approaches infinity. And I'm just going to write e to the x and then times x over x plus 1. But then I'm going to divide top and bottom by x. Remember this game from earlier in the semester? And we are getting lim x going to infinity, e to the x times, guess what? 1 over 1 plus 1 over x. Okay, too fast? Catch up. So all that to say that, okay, now when x goes to infinity, we should know that 1 over infinity is 0. Actually, that's a later problem. Here it is. 1 over infinity, or something over infinity, is 0. Okay? So in this case, I didn't mean for this to be this elaborate. We get e to the infinity times 1 over 1 is 1. So we're looking at infinity times 1, and the answer, of course, this time it diverges to infinity. Wow, that took longer than I thought. Okay, because I set up a pretty good problem there. Okay, so still kind of know if we get infinity times a number, it's infinity. If we get 0 times a number, it's 0. If we get 0 divided by 0, it's 0. What about a number divided by 0? What happens there? Remember that one? If you were to say plug into this one, limit as x goes to 0 of cosine, you're going to get cosine of 0, I guess I like that guy, divide by 0 squared. Actually, it's just a play on the first one we did. So we're getting 1 over 0. Who wants that one? Anyone? 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 Well, in that case, this is where we had to do it could be plus or it could be minus infinity. Which one is it? So you'd have to plug in numbers, and I see my mistake. The bottom is always positive. Cosine, oh yeah, that's cool. So cosine is it doesn't matter if you are approaching 0 from the minus or the plus in this case, because this bottom guy is squared, so he's always positive. And cosine of 1, cosine of 0 is 1, that's positive. So we erase the plus minus, and we say the answer is infinity. I'm just reviewing the stuff that we already know. In fact, this might be a first video, a take at this guy, and then I'll go for the others. So maybe we'll do it that way, okay? When we get to the indeterminate forms, we'll make another video. Okay, so what I'm doing is just kind of reminding us how we take limits in these cases. All right, this one, infinity over a number. Well, here we have limit as x goes to infinity. We get the following. We get, okay, infinity. It's an unbounded number upstairs. And then tan inverse of infinity. And of course, I picked that one. He's my favorite. It's infinity. Tan inverse of infinity. Who wants it? You got it. Pi over 2. Okay, but so what? The numerator gets so huge, it's only 1 billion Google or whatever over pi over 2. And so this guy, again, is infinity. I'm starting to see a pattern that if 0 is involved with these guys, we get 0. But look at this one. If 0 is involved here, we got infinity. If infinity is being plugged in, we get infinity, we get infinity. But here's another one where infinity is downstairs. What happens here? And a lot of students forget about this. So I'm boxing in these little so-called determinant forms, right? All right, plugging, let's see, x is going to 0 from the plus side. So here's 0, and we're approaching from here. And plug in. So I'll say I'm getting e to the 0 over natural log of 0. I got to know these curves. Yes, you do. Yes, you do. Make sure that you know this. So here is e to the x, and here is its inverse, natural log of x. Okay, we should burn those into your memory. What happens at e to the 0, we kind of know is 1, huh? We're talking about right there. Natural log of 0, look what it does as it approaches 0 from the plus. It goes to negative infinity. Well, when you get a number divided by a bigger and bigger and bigger number, guess what? You go to 0. Interesting. Look what the patterns are. If you get 0 downstairs, you get infinity. If you get infinity downstairs, you get 0. That's something they call inversely proportional, okay? So what I've done here, take a look at these guys one more time and say, yeah, I can take those limits. I don't know about that one. Yeah, we'll work on that one. And all these guys, we should put back into our memory cells so that we know what those limits are. The reason is when we get to the real work and the homework, sometimes we fall back on, you do L'Hopital's, and it turns into one of these guys. So we need to know these guys to do the homework. Okay? What about these guys? What about if you get 0 and downstairs you get infinity? Where would that happen? Let's make one up. Let's say I have lim and x is approaching 0, say, from the plus, and you can go something like x over, well, let's make it go enormous. So I guess I can play around with natural log of x again. In that case, what you get is 0 over minus infinity. What happens there is you get the numerator shrinking and the denominator growing at the same time, and the ratio ends up being, my goodness, of course it's going to 0. It has no choice. And this one, this guy, if you get this form, whatever you want to make up, he's going to go to infinity because the denominator gets smaller, smaller, smaller. And it's good to look at that. If the denom goes to infinity, the ratio goes to 0. If the denominator, goes to 0, guess what? Ratio can go to infinity, and vice versa, okay? That's what's kind of interesting about that. So I'm looking at these last two as truly going to 0, or in this case, truly going to infinity, because not only is it's not like I've got 0 over, say, a number, which was this guy. Okay, I got 0. I got a 0 over a number that grows to infinity. It's doubly going to 0 in this case. So that's a brief review. I'm going to end the video and make another one, go on to the indeterminate forms. Okay, so bite-sized pieces.